Hey mathematicians, Mr. Coleman here. We're going to talk a little bit about exponents today, and we're going to use a specific exponent. We're going to use 2 as our exponent. So when you see a number, when we talk about exponents, first we have a base. So let's say our base is 3. That's the number we're starting with, and we're doing 3 times 3. Sorry, it's a little sloppy. I'm using this little pad. It's a little hard to write with, but bear with me. So we have 3 times 3, and we can also say, we can write that another way. We can say 3 with an exponent of 2. So our base number is 3, and our exponent is 2. That's the exponent right there. And together, these are called power, because they have the power. We're going to focus on the exponent 2. So if we have 3 with an exponent of 2, 3 to the second, there's another way that people say that. Do you recall what it is? You can maybe ask somebody right now, what happens when the exponent is a 2? What do we call it? You got it? We call it squared. We say that's 3 squared. Okay? So do you ever wonder why we call it squared? Why is it called 3 squared instead of 3 to the power, or 3 to the second, or 3 with an exponent of 2? We call it squared. Well, let's take a look at what happens when we have 3 times 3. So if I take one of these geoboard, this is a little geoboard, and I take a rubber band and I start here and I go, oops, still have my pen. I'm going to close my pen, which is going to take my writing away. Take the rubber band. Oh, still have my rubber band. Oh, I have to take the rubber band. There we go. So I have that there, and we went up 1, 2, 3. So there's the first part, and then I'm going to go over 1, 2, 3, just like a rubber band, and I'm going to go 1, 2, 3 there. So if I get my pencil back, so I'm going to erase this little line right here, sorry. So we get that back. So you notice we have 3 on this side and 3 on this side. So we did 3 times 3. We have 3 squared. And what do you notice about the shape? It's a square. Absolutely, it's a square. So we have 3 times 3. If it's 3 going up and it's 3 going to the side, then it's going to turn out to be a square because the other sides are going to match it. That's the thing we know about squares, is all the sides are the same length. Okay? So that shows us why we say 3 squared, because we're actually making, if we were to draw it out, we would actually be making a square. Let's try another one. I'm going to grab another rubber band, yellow. Oops, I just turned it yellow. I think I need to get rid of my pen. I'm going to grab a rubber band. I'll grab a green one. I'm just going to go on the top of this one, and we'll go 5. And then we'll go over 1, 2, 3, 4, 5, and we'll bring it down. And what do you see there? What do you see there? Now we have 5 here, and we have 5 on this side. So we have 5 times 5. So 5 times 5 is the same thing as saying 5 squared. So this is showing 5 times 5 as a power. This whole thing is a power. And then if we want to find the value of 5 times 5, or 5 squared, then we're going to count up, we're going to calculate the area of that square, and it's going to be 25. And the same thing down here, if we want to get the value of 3 or 3 squared, we're just going to say 3 times 3 is 9. And notice we have a square. You want to do one more? Let's do one more. Let's do as big as we can go. And I think this is, oh, I got my pen still. Sorry, my bad. We're going to go up, and I think that's 9. Let's see if it turns out to be a square. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'll pull this down here. So now we have 9 times 9, Well, we have 9 squared. So 9 squared is going to be the same thing as 9 times 9, and it's going to have a value of 81. So to make a perfect square, you take a number and you multiply it by itself, or you take a number and you square it. Is 24 a perfect square? Can you make a rectangle, or can you make a square that has a whole number factors that are the same? We can do 6 and 4. Let's try that. Get rid of my pen. Let's try 6 and 4. I know works. So we can go, we can go 1, 2, 3, 4, and then we can go up 1, 2, 3, 4, 5, 6, and match that. Now, this is 24. It's 6 times 4. It's 6 times 4, but is that a square? It's not. So that can't, 24 is not a perfect square. Okay? When you think about squared, or you think about why we say a number with an exponent of 2 is a square, well, now you can see why. Because when we draw it out, a 3 by 3, a 5 by 5, a 9 by 9, they're perfect squares. The sides are all the same size. Okay? Awesome? And hey, it's math, so let's have some fun with it. Thanks for watching.